Hello, dear students. I hope you all are well and enjoying your studies while staying at home. So all the very best for your exams. So this video is the part 3 video of our Differential Calculus video series. And in this video, we will be focusing our attention on the rules of log and exponential functions. So these are the only two rules which were left. So we'll study these two rules in detail in this video. So before jumping to the log function, first understand what is implicit differentiation. So in the earlier examples also, you must have noticed that y was given as a function of x, that is y is equals to some function of x. So all the equations which we have seen so far, all were explicit function in which y was expressed as a function of x. But sometimes what happens, y is connected with the x in the equations which is expressed as function of xy equals to 0. So these cases are the cases where y is said to be an implicit function. For example, see this equation. In this equation, y is connected along with x. So this is not explicit function, this is implicit function, and it is not right to convert the explicit function into the implicit function into the explicit function, because it will consumes a lot of time. So in this case, you can directly find the derivative of this equation, and it is very easy. So suppose this is the equation and this equation is the sum rule. So we have to use the sum rule. So we'll find the derivatives of each these variables individually, and then we'll add the sign, that is plus sign, in all the variables. So first is the derivative of x4 plus derivative of y cube plus derivative of xy is equals to derivative of x. So we'll just find the derivatives of these variables individually. So first derivative x4, we know that this is in power rule. So it will be 4x raised to power 4 minus 1. So this will be 4x cube plus, now y cube, this is also in the power rule. So it will be 3 into y raised to power 3 minus 1. So it is 3y square. But since this is y cube and not x, and we are finding the derivative with respect to x, so in this case, we'll again find the derivative of this y, that is dy by dx. Plus, now this is the product rule. So first function as it is x, derivative of y, so this is single y, so this would be dy by dx, plus second function, that is y, derivative of x, which we know is 1. So this is only plus y, equals to derivative of 0. We know that it is a constant, so it is 0. Now take dy by dx as common. So 4x cube as it is plus dy by dx common. So it will be 3y square plus x plus y equals to 0. Now you will simply shift all the variables to the right hand side apart from dy by dx. So this will be equals to minus y minus 4x cube, and since this is in multiplication of dy by dx, this will come in the denominator. So this is 3y square plus x. Simple. Now we'll move to the log function. So how we can find the derivative of log function? There are two methods. So first is, if y is equals to log x, then the derivative of log x is simple 1 by x. And if y is a function of log ax, and where a is greater than 0 and not equals to 0, then the derivative of log ax will be equals to 1 divided by x log a. So for example, if it is log 10x, then it will be 1 by x log 10. So you'll just simply have to substitute the value of a in the formula. So for example, your y is expressed as this, that is y is equals to x raised to power x. Now we cannot use the power rule. Power rules are used when the power is in numbers, but now it is variable upon variable. So in this case we have to take log on both the sides. So log y is equals to log x raised to power x, and you know that one of the power rule of log, the value of this will be equals to x into log x. So this x will come before and then log x. After that you have to take the derivative. So derivative of log y equals to derivative of this x log x. So we know that the derivative of log y is 1 by y, but since it is not x, so we'll take further derivative of y, that is dy by dx, equals to, this is the product rule. So x derivative of log x plus log x derivative of x. So now we know that the derivative of log x is 1 by x plus log x derivative of x is 1. So this will be, x and x will get cancelled. So this will be 1 plus log x. Now again you can shift this y to the right hand side. So this will be multiply this function. So it will be y into 1 plus log x, and now you can simply substitute the value of y, that is x raised to power x. So this is the differentiation of the function, that is x raised to power x. Suppose you have this example now where log is a log function of 6x cube plus 8. So now we know that the formula for finding the derivative of log x is 1 by x. So we'll simply divide this. So 1 divided by 6x cube plus 8, derivative of again this function, because this is not x. Whenever it is not x, you have to again take the derivative of that function. As you have noticed in the example 1 also, where it was log y, in that case we have written dy by dx. So in this case it is not x, but this is 6x cube plus 8. So we'll further take the derivative of this function. So this will be 6x cube plus 8 derivative. So now the next is derivative of this. This is power rule. So it will be 18x square. Then sum rule plus the derivative of constant is 0. So this will be 18x square divided by 6x cube plus 8. So this is the derivative of the y. Now we'll move to the exponential functions. There also they have two formulas. So if the function of x is the exponential x, then the derivative of x is also exponential raised to power x. So the derivative of ex is ex. But if the function is given as a raised to power x, where a is greater than 0 as well as not equals to 0, in that case the derivative of x will be ax into log a x. Sorry, this you have to, this is just a, this is wrong. So read it from there. So if function of x is a raised to power x and a is greater than 0, not equals to 0, then the differentiation of x is ax into log a. So for example, if it is given as 10 raised to power x, then in that case it will be 10 raised to power x multiplied by log 10. Okay. So for example, this is the equation 4x cube plus 9x. So this is the sum rule. So 4x cube, this is the power rule. So it will be 4 into 3, x raised to power 3 minus 1. So it is 12x square plus 9x. So this is your exponential function in which we have to use this formula. So this will be 9x into log 9. So this is the answer. Okay. Next question is, suppose this is the equation and this is the quotient rule which we have to use. So quotient rule says denominator whole square, then denominator as it is derivative of numerator minus numerator as it is derivative of your denominator. So this is as it is. Now derivative of 6ex is 6ex only, क्योंकि 6 is the constant, so it will not multiply with anything, and the derivative of ex is ex. So this is 6ex, then 6ex as it is, then derivative of 2ex plus 3 is 2ex plus 0 because we know it is a constant, and this is 2ex plus 3 raised to power 2, so this is same. Now you can take 6ex as common, so it will be 2ex plus 3 minus 2ex, so 2ex and 2ex will get cancel, so this will be 18ex divided by 2ex plus 3 whole square. So I hope this is clear. Now the next important function is the derivative of inverse function. So sometimes what happens, the question says that instead of dy by dx, find dx by dy. So it is very simple. Inverse function is formed when the independent variable is exchanged with the dependent variable in the equation. So in the usual question, y is your dependent and x is your independent. But sometimes x becomes independent and y becomes dependent. So when we rearrange the equation, in that case, your equation y is equals to fx turns into x is equals to gy. Then this x is equals to gy is called the inverse of this function. So it is very simple. You just have to reverse the dy by dx. So this is the formula. So in case your equation is y is equals to 5x square, so the derivative of y with respect to x is 10x, and in case you have to find the this is dy, so dx by dy, so in this case it will be 1 by 10x. So you just have to take the inverse, so you just have to divide it. Okay, so it's very simple. Next important function differentiation part is the successive and higher order differentiation. So the process of differentiating a given function again and again is called successive differentiation, and the outcomes of such differentiation is known as the successive and higher order derivatives. So you can use the simple steps for calculating the higher order derivatives. So suppose your function x is a differentiable function of x, then f dash x. So f dash x is your first derivative of the function f. So whatever rules we have learned so far and whatever equations we have solved so far in order to derive the derivative, all these are the first derivatives. Now in order to find the second derivative, what you have to do? You have to take again the derivative of the first derivative. So whatever your answer is there in the first derivative, you again have to apply the rules in order to find the second derivative. And in case of finding the third derivative, you have to take the derivative of your second derivative. So you have to take the derivatives again and again, whatever your order of derivative is required. So if it is n order of derivative, you have to take the derivative of n minus 1 derivative. Okay. For example, this is your equation y is equals to this. So in case of finding the first derivative, that is dy by dx, it will be derivative of 5x4, derivative of 3x square, derivative of 7x square, derivative of 10x and derivative of 50. So this is the sum and difference rule which we have applied. So this will become 20x cubed, this will be 9x squared, this will be 14x, this will be minus 10, and this is constant, so it is 0. So now in order to find the second order derivative, we further have to take the derivative of this equation. So this will be 60x square, 18x plus 14 minus 0. And in case you have to find the third derivative, so again we have to take the derivative of this equation. So this will become 60 into 2, 120x, that is x raised to power 2 minus 1, plus 18x will be 18. And 14, it is 0. So this is your third order derivative. I hope this is clear. Thank you for watching this video, and please like, share and subscribe my channel. It is very important for my growth, and thank you so much. Please enjoy the videos and click the bell icon in order to get the regular updates. Thank you and bye bye.